Okay, so what we did last time was we basically defined DFT, discrete time discrete Fourier transform. Discrete Fourier transform. And if we want to move from n domain to k domain, it is defined like this. It is summation n changing 0 to n minus 1, where n is the number of samples in xn. Then the Tweedle factor. Tweedle factor is e raised to power minus j 2 pi by n k. Okay, this is DFT. And what is inverse DFT? Inverse DFT is when we move from k domain to n domain. So xn is given by 1 by n summation k changing 0 to n minus 1 e raised to power xk e raised to power. Here Tweedle factor has negative value, यानी कि plus j 2 by n and nk. Okay, where Tweedle factor is called, Tweedle factor किसे कह रहे हैं हम? Tweedle factor is represented by Wn equal to e raised to power minus j 2 pi by n. This is the definition of discrete Fourier transform and inverse discrete Fourier transform. Okay. Are you able to see this SciLAB console? DFT, we have to find out DFT using definition. We have to find out DFT using definition. Okay, so let us suppose xn is a sequence which is given by, suppose 1, 2, 3 and 4. Let us suppose this is xn. Okay, this is xn, and we want to find out its xk, DFT. So what will be DFT? DFT will be the formula which we have just जो आपको पहले दिया, just discussed. So DFT will be having 4 values. Let us find out xk0 first. What will be xk0? Xk0 will be x0 is 1, xn0 is 1 into exponential minus 2 pi minus j. Minus j is percentile iota minus j into 2 pi into 2 into pi percentile pi. This will be 2 pi divided by 4, because there are 4 samples in this signal, into what? This is your Tweedle factor. Okay, this is your Tweedle factor, and into nk. Now value of n is 0 here and value of k is also 0, so it will be 0. Okay. Plus, let us copy this expression, it will help me out. Then 2 into, now n की value is here 0, यहाँ पे n की value is 1, but k की value is 0, therefore it will be 0. Okay. Then 3 into, here also k की value is 2, but n की value is 2, but k value is 0, so here it will be 0, and so this will be your 0, 1, 2, sorry, यहाँ पे 2, 1, 2, 3 and 4 भी आएगा, plus 4. Here also k की value is 0, but n value is 3. Okay, so this will be your x0, जो हमने अभी ये एक्सप्रेशन पढ़ा था इसके हिसाब से. ओके, ये वाला एक्सप्रेशन डिस्क्रीट फोरियर ट्रांसफॉर्म में हमने इसमें. ओके, so this will be your xk, xk0, this will be your xk0. Okay, this will be your xk0. Now what will be x1? x1 में क्या होगा, यहाँ पे n की वैल्यू 0, then n की वैल्यू is 1, then n की वैल्यू is 2, then n की वैल्यू is 3, and k की वैल्यू is 1. ठीक है, यहाँ पे k की वैल्यू is 1, so this will be xk1, this will be your xk1. Okay, now xk2, so यहाँ पे k की वैल्यू is 0, sorry, k की वैल्यू is 2 for all these terms and n की वैल्यू is 0, then 2 into 1 will be 2, then 2 into 2 will be 4, then 2 into 3 will be 6. This will be your xk2, this will be your xk2. ये -2 है and this is 0, so 10 raised to power minus 16 is 0, so we can ignore this part. Imaginary part is 0 for this. Okay, then next will be xk3. xk3 will be equal to 1 into, sorry, xk3 will be, यहाँ पे k की value is 3 for all the terms and n की value is 0, then n की value is 1 यानी कि 3, then n की value is 2, 2 into 3 will be 6, and here the n की value will be 3 into 3 will be 9, 3 into 3 will be 9. So 3, 6 and 9, 0, 3, 6 and 9. This will be x3, xk3. So this will be your xk. So that is how you can find out discrete Fourier transform using definition in SciLAB. Is it clear? Third year.
Yes, sir, clear.
Okay. Now let us find out the inverse discrete Fourier transform using this definition. Okay. Now we have xk's, values of xk's, we will be obtaining xn again. Okay. So for that, IDFT using definition. Okay. So what will be xn0? xn0 will be xk0 into exponential plus j. इसमें plus j होता है, So percentile I into 2 into percentile pi, okay, divided by again 4. This will be Tweedle factor minus and into 0 into 0. Okay, this will be first term. Let me copy that. Copy. Then xk1, here it will be also 0, plus xk2, sorry यहाँ multiplication आ गया, xk2 multiplied by this thing plus xk3 जो अभी हमने निकाला है xk3 into this. So this will be your xn0 and of course यहाँ पे इसे 1/4 से डिवाइड भी करना पड़ेगा, सॉरी 1/4 से मल्टीप्लाई करना पड़ेगा, तो इसको हम 4 से डिवाइड कर देंगे. यहाँ पे एक और ब्रैकेट लगा के इसे 4 से डिवाइड कर देंगे. सो दिस विल बी योर xn0 from moving from k domain to n domain. Okay, so this will be your xn0. कितना आना चाहिए ये xn0 कितना आना चाहिए, अभी किया हमने, शुरू में लिया था ना. xn0 कितना होना चाहिए, what was xn0 थर्ड ईयर, बताइए. 1. Okay, so let us see it is coming out to be 1 only. Okay, so it is 1. Of course this is 0 because it is 10 raised to power minus 16. It can be ignored. So xn0 is 1. कंप्यूटर कभी भी 0 आपको एब्सोल्यूट नहीं देगा. So it is almost a 0. Okay, so we can ignore it in comparison to this. Now xn1 को निकालने के लिए क्या करेंगे, xn1 को निकालने के लिए यहाँ पे n की वैल्यू 1 रख देंगे. So 1 into 0 will be 0, 1 into 1 will be 1, 1 into 2 will be 2, 1 into 3 will be 3, 1 into 3 will be 3. So this will be your xn1. So its value is 2. 2 ही थी ना इसकी वैल्यू, थर्ड ईयर. Now 2, okay, 2, so 2 into 0 will be 2, 0, 2 into 1 will be 2, 2 into 2 will be 4, 2 into 3 will be 6. Okay, so this will be xn2. xn2 की वैल्यू कितनी होनी चाहिए, बताइए. 3. So it is coming out to be 3. Okay, similarly x3 into 0 will be 0, x3 into 1 will be 3, x3 3 into 2 will be 6, and 3 into 3 will be 9. Okay, इसकी वैल्यू कितनी आएगी, कितनी आएगी, 4. So it is coming out to be 4. So 1, 2, 3 and 4. So this is how we can move from k domain to n domain and n domain to k domain. So आज आपको ये करना है. Okay, write down okay in the chat box if you got this point. Rahul Gupta is present. Neeraj Kumar is present. Neeraj.